This video is going to look at solving a system by elimination. First, let's take a look at the ignite. We're going to solve the ignite algebraically using substitution. We have 4x minus 3y equals negative 42, and 5x plus 3y equals negative 39. Take a moment, try to solve that. Otherwise, remember, we have to get one of the variables solved by itself. I personally would probably solve the top one. Pause it and try it. Otherwise, I solved the top equation for y. You got y equals 4 over 3x plus 14. Now, try to solve this problem using substitution. This might be a little easier. Otherwise, that's going to look like this. We eventually get x equals negative 9 and y equals 2. Now we're going to look at another way to solve a system of equations, and that's solving by elimination. So let's use this idea on the left to solve this problem on the right. We have two equations, 3 equals 4 minus 1, and 5 equals 2 plus 3. Is that true? Does the left side equal the right side? Yes. Now, interestingly, notice that I can actually add these equations together. 3 plus 5 is 8, 4 plus 2 is 6, negative 1 plus 3 is 2. Does 6 plus 2 still equal to 8? Yeah. We can actually add equations together. Equations means equals, right? So the left side equals the right side. And when you add equations together, if the equations are equal in the first place, they're still going to be equal. This preserves the equality. Two equal things added together are still equal. We can use that idea now to apply that to other scenarios. For example, let's try to add these equations together over here and tell me what happens. I have 2x minus y equals negative 3, negative x plus y equals 4. Why don't you take a minute and try to add that together? Otherwise, it's going to look like this. We have 2x minus x is x, negative y plus y is 0y, and negative 3 plus 4 is 1. So we've just found x is equal to 1. Notice how quickly we were able to find x equal to 1. Now I can plug x back in to either the top equation or the bottom equation and solve for y. And whether you plug 1 into the bottom equation, like I did, or plugged in the top equation, you should still get y equal to 5. So we found that x is 1, y is 5. And like we did with substitution, I could verify that's true. Since I used the bottom equation for me to get y equal to 5, I'm going to check the top and make sure that that equals negative 3. And we find that the left side does equal the right side. So this is the idea of elimination. When I add two equations together, one of the variables eliminates. When I'm left with just one variable, I can solve that algebra problem. When I have two variables, I can't solve for a letter equals a number. You have to get down to just one letter in your equation, and then you can solve for a number. So let's take a look at ideas for elimination. The ideas for elimination. In this previous problem, we used an idea called elimination. We want to eliminate one variable so that we only have one variable left. This is because we have methods to solve for an equation with only one variable, solve an algebra problem. So our goal is that when you add the equations together, one of the variables is eliminated, which means adds to 0. Why don't you take a moment and figure out what the number slash variable would be so that when we add these together, it equals 0. So 3 plus what gives me 0? Negative 8 plus what gives me 0? 4x plus what gives me 0? Negative 2y plus what gives me 0? Take a minute, try to figure those out. Alright, let's look at it. 3 plus what gives me 0? That would be negative 3. 3 minus 3 gives me 0. How about for negative 8? Negative 8 and what gives me 0? That would be positive 8. 4x plus what gives me 0? That would be 4x minus 4x gives me 0. And negative 2y plus what gives me 0? That would be positive 2y. Notice, in order for them to add to 0, I had to have the same number, just one positive, one negative. If I had a negative, I needed a positive. It had to be the same number and our variable, and one positive, one negative. So let's look at solving these algebraically using elimination. And let's take a look at number 4. For number 4, we have 8x plus 5y equals 11, and 2x minus 5y equals negative 41. So to solve by elimination, what we want is when I add these two equations together, one of the variables should eliminate. And in order to eliminate, we need to add the same number, just one of them positive, one of them negative. We see here that the 5y and negative 5y should cancel. Right, I need a positive 5y and a negative 5y in order for the y's to disappear, to be 0. So take a moment, add these equations together, try to solve for x, and then plug it back in to solve for y. Otherwise, that's going to look like this. I'm going to add my equations together. 8x plus 2x is 10x. The 5y minus 5y becomes 0y. And 11 minus 41 is a negative 30. And now if 10x equals negative 30. Again, now I have an equation with this one variable. I can solve to get that number, x equals a number. Use that then and find y after plugging it back in. Again, if you haven't done so, take a moment, try that. Otherwise, we get x equals negative 3 because we divided both sides by the 10 in front of the x. So negative 30 divided by 10 is negative 3. And then we plug that back in to either top equation or bottom equation, doesn't matter. I decided to plug the negative 3 in for x on the top, so it's 8 times negative 3 plus 5y equals 11. 8 times negative 3 is negative 24, plus 5y equals 11. From here, you're just solving an algebra problem. You should know how to do that. Take a moment and solve that. Otherwise, we got y equals 7. I added 24 to both sides. 11 plus 24 is 35, so 5y equals 35. Divided both sides by the 5, we got y equals 7. So you see here that x equals negative 3 and y equals 7. Now let's take a look at number 5. On number 5, we have 6x plus 4y equals 38, and negative 6x minus 7y equals negative 62. Take a moment and see first, is there something that would eliminate if I just add these together? Is there the same number with variable on the top and bottom, but one's positive, one is negative? Which one's going to eliminate, the x or the y on number 5? We see that when we add them together, 6x minus 6x canceled to give me 0x. 4y minus 7y is a negative 3y, and 38 minus 62 is a negative 24. So 3y equals negative 24. So notice, sometimes the y's will cancel, sometimes the x's will cancel. It all depends, whatever one has the same x with a positive and negative, or the same y with positive and negative. Either way, my goal is that when I add the two equations together, I'm down to just one letter and numbers. Then I can solve that letter equal to a number. Take a moment and solve the rest of that. Negative 3y equals negative 24. Find y, and then plug it back in to find x. Otherwise, it'll look like this. We divide both sides by negative 3, so negative 24 divided by negative 3 is a positive 8, so y is 8. So we know that. Now I can take that y, plug it back in, either the top equation or bottom equation, doesn't matter. I decided to plug it in the top, so 6x plus 4 times 8 equals 38. Now we're just solving that problem. First simplify, 4 times 8 is 32. Gives us 6x minus 32 equals 38. I subtract 32 from both sides. That gave me 6x equals 6, because 38 minus 32 is 6, so 6x equals 6. Now we divide by 6 on both sides, and we got x equal to 1. So x is 1 and y is 8. So that's the idea of elimination. I want to be able to add my equations together so that when I do add them, I have a positive and negative of the same number, so that one of the variables cancels. Sometimes it's y, sometimes it's x. Now let's revisit number 6. Remember our ignite, where we had to do this much work? Now let's take a look at what it looks like when I try with elimination. Take a moment and solve that. Otherwise, that'll look like this. And we add them together, we get 4x plus 5x is 9x, negative 3y plus 3y is 0y, negative 42 minus 39 is a negative 81. We are now actually right over here. This is now exactly the same process that we did before. But notice I skipped all of this upper part. All of this upper part was skipped. We jumped right to this step, and then from there following the rest. So elimination is pretty handy when my variables are lined up with each other, typically when both of them are in standard form. Really, you could use it in any form as long as your variables are lined up with each other. Remember, I need to have a positive and negative version of the same number and letter so that when I add them together, one of the variables eliminates. Now let's take a look at preserving equality. So preserving equality. We can really do anything to an equation as long as we preserve the equality. We accomplish this by doing the same thing on both sides of the equals. The goal is often to do something to the equation so that it helps us find the answer. But let me just show you some other ideas of doing things that are so equal. Again, equations have equals that says this left side equals this right side. So 8 plus 5 is supposed to equal 13. This left side equals this right side. Because both sides are equal, as long as I do the same thing on both sides, I preserve equality. So, since I know 8 plus 5 is 13, if I let x be 5, then 8 plus x should equal 13. We know x is going to be 5, yes? What I want you to do is test whether the following preserve the equality by plugging in x into the final equation. So, for example, on A, we have 8 plus x equals 13. I added 2 to both sides. What I did on one side, I did on the other side. That gave me 10 plus x equals 15. What I want you to do is tell me, if I plug in 5 for the x, is the left side equal to the right side? Take a moment and do that. We see when I plug in 5 for the x, that's 10 plus 5 is 15. 15 does equal 15, so did I preserve equality? Yes. So I can add the same number to both sides. Can I subtract the same number from both sides? I have 8 plus x equals 13. I subtract 3 from both sides. That gave me 5 plus x equals 10. Again, plug in 5. Does that left side equal the right side? And the answer is yes. So I can add the same thing to both sides. I preserve equality. I can subtract the same thing from both sides. Preserves equality. Can I multiply both sides by the same number and still preserve equality? I have 8 plus x equals 13. I multiplied the 8 plus x by 4, so 4 times the quantity, 8 plus x, that's inside parentheses, the 8 plus x, and that's supposed to be equal to 4 times 13. 8 times 4, again I distribute, is 32. 4 times x is 4x, and 4 times 13 is 52. So 32 plus 4x is supposed to equal 52. Again, let's plug in 5 and see, does that left side equal the right side? And we see that 4 times 5 is 20, 32 plus 20 is 52, so 52 equals 52. So does multiplying both sides by the same number preserve equality? Yes. So I can add to both sides, I can subtract the same thing from both sides, I can multiply both sides by the same thing. Can I divide both sides by the same thing and still preserve equality? And we see yes, this does preserve equality. 8 plus x equals 13, I can divide both sides by 2. That gives me 4 plus 1/2 x equals 6.5. Plugged into 5. 5 times a half is 2.5, so 4 plus 2.5 is 6.5. We see that is equal to the right side, 6.5. So again, preserved equality. Now, it should be noted, these are not actually proofs. That doesn't show that that's always true. You can't use specific numbers to show that this idea works. But this is a specific example to kind of help you illustrate that fact that we already know in mathematics. Another thing to note, notice that none of this really helped me solve the problem, but like I said, I changed the problem to a different problem that maybe it's easier for me to solve. So that's something that you can do by preserving equality, is changing your initial equation into something that's easier to solve, which is what we're doing when we solve by elimination. We saw in the previous problem that we can add, subtract, multiply, and divide on both sides of the equation and still preserve equality. I know those operations helped us solve for x, but our equation was still equal. We can use the idea of preserving equality to solve equations that actually help us. For example, 8 plus x equals 13. I can subtract 8 from both sides, and notice I get x equals 5. That's how I can solve a problem. Let's take a look at number 8. Did the following operation preserve equality? Select the answer from the operation. Remember to test x equal to 5 to see if the equality is preserved. If equality is not preserved for A, B, C, or D, explain why the action did not preserve equality. So I have 8 plus x equals 13. I subtracted 8 and subtracted 8. So my question is when I subtract 8, like I did, is it the answer for A, x minus 8 equals 13? Is it B, negative 8x equals 13? C, negative 7x equals 13? D, 16 minus 8x equals 13? Or is it choice E, none of the above choices are equivalent to 8 plus x equal to 13? Take a moment and figure out which of those it would be. So when I plugged in 5, notice on A we have 5 minus 8 is supposed to equal 13. That's not true. When you have an equal sign but you draw the line through it, then it says not equal to. So it says the left side is not equal to the right side. Negative 8 times 5 is supposed to equal 13. Again, not equal to. Negative 7 times 5 is supposed to equal 13. Again, not equal to. How about D? 16 minus 8 times 5 is supposed to equal 13. Again, not equal to. So you see that my answer is E. None of these above choices are equivalent to 8 plus x equal to 13. The problem then is what? Well, notice I subtracted 8 from the 8, but I also subtracted 8 from the x. I didn't do it on both sides of the equation. I did minus 8 on the same side of the equation. Problem is I subtracted 8 twice on the same side of the equation. It should be minusing 8 on the opposite sides of equals. Or there's another way to deal with it. Let's take a look at number 9. Explain whether the following preserved equality. If not, explain what's wrong. I have 8 plus x equals 13. I have 8 minus 5 plus x equals 13. If I plug in 5 for x, does it preserve equality? Well, it turns out it actually does. And that's because negative 5 plus 5 is a total of 0. We're adding 0 to that side. So I can add a total of 0 to the same side because that doesn't change my overall answer, right? 8 plus 5 is 13. So as long as I have a positive and negative on the same side of the same number, I'm okay. So let's summarize that. So I can either subtract the same thing from both sides, or do the same thing on opposite sides of the equals to preserve equality, or we can do the opposite thing on the same side of the equals to preserve equality. Here I added and subtracted 5. So if you do things on opposite side of the equals, you need to do the same thing, right? Whatever I do, I need to do on both sides, keep it fair. Or if I do it on the same side of the equation, then I need to add and subtract. These are really two ways that we can deal with keeping equality. Most of our stuff is going to be this first method, but I want you to be aware of the second method of ways you can preserve equality. It's actually really useful when we complete the square when we get into quadratics. For right now though, most of the time you're going to solve using this first method. So remember, do the same thing on opposite sides of the equal sign. Now let's take a look at what happens when they are not opposites of each other. So number 10, how can we eliminate the x's when we add the equations together? Again, think of ways that we change the equation but preserve the equality. I have 3x minus 5y equals 37, and 3x plus 8y equals 11. How could I possibly get rid of the x's? Notice I have a positive 3x. What do I need the other one to be so that when I add it together, the x's cancel? Well, one of the ways we can do this that we just talked about is we could subtract, or essentially multiply by -1. When you do this, you need to do it to the whole equation. Remember, what I do on one side of the equals and you do on the other side of the equals. You can do this by putting parentheses around the whole thing. One of the things I find kids don't do very well is remembering to essentially distribute this negative through. This is why I think this actually is a -1. And I tend to just rewrite this whole thing so that I can just add my equations together. So I kept the top equation the same, 3x minus 5y equals 37. Bottom one, again, if you're subtracting, you're essentially turning these all into the opposite sign. So I get -3x minus 8y equals -11. It's only because they were all positive that they all turned negative. If one of them was negative, then it would have turned into a positive. Now I have a positive 3x and a negative 3x. Now if I add my equations together, one of my variables will eliminate, and that will eliminate the x. Try to solve the rest of this. Essentially what we did is we subtracted, or again, you could think of it as actually as multiplying the same thing on both sides. In either case, solve the rest of that. Otherwise, that'll look like this. The 3x minus 3x canceled, give me 0x. Negative 5y minus 8y was negative 13y, and 37 minus 11 was 26. I divided both sides with a negative 13 in front of the y. 26 divided by negative 13 is a negative 2. I then plugged in negative 2 in either the top equation or bottom equation. I decided to do the bottom equation. Since it's all positives, I thought it would be easier. So 3x plus 8 times negative 2 is supposed to equal 11. 8 times negative 2 is negative 16. I added 16 to both sides. 11 plus 16 is 27, so 3x equals 27. Divided both sides by 3, so x equals 9. I could then verify that if I wanted to. Since I used the bottom equation to get to x equal to 9, I need to check the top equation. So I plugged in x is 9, plugged in negative 2 for the y, and I saw that the left side does equal the right side. Now, one of the things I didn't show on this video is I actually had positive 2 here for the y, and then I wrote 37, I mixed the two equations together, and when I went to go check it, I realized, hey, I actually have the wrong answer, so I actually went back and had to fix all of it. So again, this is a good reason to check your answer. You never need to ask a teacher, hey, is this right? You can check and verify yourself. Now let's take a look at 11. We're going to use the same idea as we did, but this time we want to eliminate the y's. Take a moment and see if you can do that. Otherwise, again, that'll look like this. I essentially multiplied everything by negative 1. So we have 5x plus 2y equals negative 7, and negative 8x minus 2y equals positive 16. Remember, all the signs flip to the opposite sign. Now when I add them together, one of the variables should eliminate. We have a positive 2y, negative 2y. My y's will cancel. So 5x minus 8x is negative 3x. Negative 7 plus 16 is positive 9. I divided both sides by negative 3, so 9 divided by negative 3 is x equal to negative 3. I plugged in negative 3 then in either the top equation or bottom equation. I decided to do the top equation. So 5 times negative 3 plus 2y equals negative 7. 5 times negative 3 is negative 15. So negative 15 plus 2y equals negative 7. Add 15 to both sides. We get 2y equals 8. Divide both sides by 2. So that's the number in front of y. We got y equals 4. So x equals negative 3. Y equals 4. Again, I can check that if I want to. Use the top equation to get the y. So I need to check the bottom equation, make sure it works in there as well. And we see that the left side does equal the right side, so that's true. So we know for sure that we have the correct answer. Now let's take a look at two more problems. On number 12, how can we eliminate the x when we add the equations together? Again, we're trying to think of ways we can change the equation but preserve the equality. Here's 6x plus 5y equals 18, and 2x plus y equals 10. Now notice this time, if I'm trying to get rid of x's, and again, I could get rid of y's, I'll show you that on the next problem on 13. Normally, I could have just added, but 6 and 2x aren't the opposite of each other. Couldn't subtract, because again, it's not both 6x. So I need to figure out, how can I get the x's to cancel? If this is a positive 6x, what do I need the bottom one to be in order to, so that when I add the equations together, it cancels? Take a moment, see if we can figure that out. Otherwise, we're thinking I need the bottom then to be a negative 6x. So what do I need to multiply by in order to get negative 6x? 2x times what gives you negative 6x? Or to think negative 6 divided by 2 is negative 3. So we're going to multiply this entire thing by negative 3. So when I distribute it, I get negative 6x minus 3y equals negative 30. I'm now going to add that to the top equation. 6x plus 5y equals 18. Again, it doesn't matter if I switch the order, they're still both equal equations. So now the top equation is moved to the bottom, but it doesn't matter. Now I'm just adding my equations together, and one of my variables should eliminate. Remember, I was trying to eliminate x in this context, and we get 2y equals negative 12. Again, my negative 6x and positive 6x canceled. Negative 3y plus 5y is positive 2y. Negative 30 plus 18 is a negative 12. And now I'm just solving the algebra problem. Use that, plug it back in to get x. We see we get y equals negative 6 when we divide both sides by 2, so negative 12 divided by 2 is negative 6. I can now use that y, plug it back in, either the top equation or bottom equation, and find that. When you do plug it back in, plug it into the original. Just one last extra step. I want to plug it into the 2x plus y equals 10. So I have 2x plus negative 6 equals 10. That's really 2x minus 6 equals 10. I added 6 to both sides, so give me 2x equals 16. Divided both sides by 2, and got x equals 8. So x equals 8, y equals negative 6. Again, you could check that if you need to, plug that in to verify. Since I used the bottom equation, I'm going to have to use the top equation, the 6x plus 5y equals 18, and check that. And we should find that that's actually correct anyways. Now let's take a look at 13. On number 13, we have the same problem. 6x plus 5y equals 18, and 2x plus y equals 10. This time, though, I want you to try to eliminate the y's. So I have positive 5y, positive y. I need to get them to be opposite of the same number. So if it's positive 5y, what should I have the other one be? Take a moment, try to solve this problem. Otherwise, we'll do something similar to what we did with number 12. But we're, again, trying to get rid of the y's. And that looks like this. I'm multiplying by negative 5. Since I have positive 5, I need the bottom to be a negative 5, so I'm multiplying everything by negative 5 on the bottom equation. Again, make sure you distribute to all of the parts of the equation, giving us negative 10x minus 5y equals negative 50. I'm now going to add that to my top equation. 6x plus 5y equals 18. And so I have negative 10x plus 6x is 4x. Negative 5y plus 5y cancels, and negative 50 plus 18 is 32. So we have 4x equals 32. Again, try to solve the rest of this, find the y, otherwise it's going to look like this. We divided both sides by 4, so 32 divided by 4 is 8, so x equals 8. Plugged it in, again, you can plug it in the top or bottom. I plugged it in the bottom, so 2 times 8, so that's in place of the x. Plus y is equal to 10. 2 times 8 is 16, so 16 plus y equals 10. I subtracted both sides by 16, so 10 minus 16 is negative 6. Notice the same answer from 12 and 13. It is the same problem, so it should be the same answer. Again, that's how I can verify it's correct. Normally, you don't have to pick which one you want to eliminate. You could eliminate x, you could eliminate y. Typically, it doesn't tell you which one to do. So either way would have worked on this problem. So in summary, we can solve any linear system by elimination by using addition when one of the variables is already opposite of the same number, positive and negative of the same number and variable. Subtract when the variable, one of the variables already has the same sign of the same number, right? So like both positive 5x or something. Or we can multiply one or both equations to get the opposite signs that we need, with one being the positive, one being the negative of the same number. So when we add the equations together, again, the goal is that one of the variables is eliminated. You should be able to solve these other problems then, 14 through 20. Pause it and try to answer the questions. Again, you know how to check your answers by plugging them back in, make sure they work in both the top and bottom equations. And that's how you know if you're right. Let's take a look at number 14. We have negative 8x plus y equals 2, negative 7x minus y equals negative 17. Which one's going to eliminate if I add them together, x or the y? You see, I don't have to do anything. The y is already positive and negative of each other, so we should be able to just add those together. If you haven't done so already, try to just add the equation together and solve. Otherwise, that work will look like this. When I added them, negative 8x minus 7x is a negative 15x. 2 minus 17 is negative 15. So negative 15x equals negative 15. So positive y, negative y eliminated. from there, solving the algebra problem, got x equal to 1, plugged in 1, either top or bottom, got y equals 10. Again, checked to verify, saw it's true, so I know that I'm correct. X equals 1 and y equals 10. So in this problem, we were just able to add to eliminate. Now let's look at number 15. 2x minus y equals -1, and 3x minus y equals -9. See if you can solve this problem. Otherwise, we want to try to eliminate one of them. And we see here I have -y and -y. I need one of them to be a positive y, so I could really just multiply one of them by -1. Remember to distribute to all those. That flips all of the signs. So we get -3x plus y equals 9. The top equation I moved below to say 2x minus y equals -1. Now I can add my equations together and my y's eliminate. If you haven't done so already, try to solve the rest of this. Otherwise, that'll look like this. I'm going to add them together. Add -3x plus 2x was -x. 9 minus 1 was 8. One of the most common things I see students forget is this is -x, not x. I want positive x equal the number. Right now in front of x is actually a -1. And so I divide both sides by -1, we get x equals -8. Plug that back in, 2 times -8 minus y equals -1. 2 times -8 is -16, minus y equals -1. I added 16 to the side, but again, have that negative y, so I had to divide by -1 to get y equals -15. I checked, saw the left side does equal the right side, so x equals -8, y equals -15 is our answer for number 15. And we see the method that we used here was subtraction to get elimination. Now let's look at number 16. 7x plus 3y equals -5, and x minus 6y equals 25. See if you can solve this problem. Remember, we want one of them to be a positive of a number, and then also the negative of that same number. It looks like we can't just straight up add or subtract. So what do you want to get rid of? You want to get rid of x or y, and then you're going to have to multiply one, maybe both of the equations, in this case only one of the equations to eliminate it. If I wanted to eliminate x, on the top I have a positive 7x, so on the bottom I need that to be a negative 7x. So I'm going to multiply the bottom by -7. We get -7x plus 42y equals -175. Top equation was 7x plus 3y equals -5. Now we can add it together, my x's cancel, and solve the rest. Or if I wanted to eliminate y, I see that I have a -6y, so I need the top to be a positive 6y. So what do I need to multiply the top by to have positive 6y if I'm already have 3y? That would be multiplying the top by 2. That gave me 14x plus 6y equals -10. Remember, make sure you distribute a 2 throughout the whole thing. And now I can just add my equations together and my y's will cancel. Find the x and then plug it back in to find the y. That looks like this. Notice in either case we get x equal to 1, y equal to -4. On both these, my way of solving it is I had to multiply in order to eliminate. Now let's look at number 17. Number 17 is y equals 2x plus 4, and then 3x minus 9 equals 9. See if you can solve this problem. Otherwise, first thing we're going to want to do is get our variables lined up. So I need to move this positive 2x to the other side and put it in the standard form. So I subtracted 2x on both sides, they give me -2x plus y equals 4. Make sure that your x's are lined up, make sure your y's are lined up, numbers are lined up. Now you can consider, do you want to get rid of x or do you want to get rid of y? Either way will work, as we showed. You're still going to get the same answer. It's up to you which one you want to do it. I personally would probably try to eliminate the y, since this is a -9y on the top. I would actually just multiply this by 9. Multiply everything by 9. That would give me a positive -9y, and then it would eliminate. However, I haven't shown you an example where you multiply the top equation and you multiply the bottom equation. So I'm actually going to show multiplying so that I can eliminate the x's. What you want to think of is a common kind of like denominator idea called your least common multiple. And this is negative 2x, positive 3x. Thinking, what do they kind of have in common? So I think of like trying to make a common denominator of a fraction. That would be 6. So I need a positive 6, negative 6. So I'm going to multiply the top by 3 and the bottom by 2. This gives me negative 6x plus 3y equals 12, and 6x minus 18y equals 18. Now I can add them together and my x's will eliminate. Try to do the rest of this, otherwise it'll look like this. And we eventually get x equal to negative 3, y equal to negative 2. You need to do 18, 19, and 20 on your own. Again, you can check your answer by plugging it in, see if it's correct.